Please introduce yourself and briefly summarize your education and professional background.
My name is Dan Isaacs. I am the CTO and the GM for the Digital Twin Consortium. I'm also the Chief Strategic Officer for the OMG umbrella of community of consortia that we have. And my background, let's see. Started out, I have a degree in geophysics. I have a degree in computer engineering. I have 10 years experience in aerospace and defense. I have 10 years plus in automotive and 15 plus in semiconductor. From my previous company, I represented a previous company, which was Xilinx. They were acquired by AMD a couple of years back. I represented the company to the Industrial Internet Consortium. That is one of the consortia that existed back in, I think it was founded in 2010. Karen, you can correct me, but that was through IBM, Cisco, Intel, AT&T, and GE. And the whole objective there was to talk about what is that, what is it in the context, technologies, capabilities, all the rest of these areas, methodologies, architectures, frameworks, in the context of the industrial internet. So what are those areas? And one of the first things that came out really pivotal from that perspective was a paper on security and trust. And from there, went on and they developed really what attracted me to supporting that was in the context of the test beds, actually building, not just doing the white papers, foundational areas, yes, absolutely, but app notes, these types of things, but really building these and innovating and showcasing that value through real world applications that you go from concept to actual implementation. And I spearheaded two of those test beds. One was around security claims. How do you evaluate the security from that? We did that with Underwriter Laboratories, and that grew to bringing in over, I think there were over 15 different companies from that perspective that we brought in as part of that, building out that ecosystem around that. From there, the second test bed spearheaded was around using machine learning for predictive maintenance to bring intelligence to the factories and do that in a way that we started with a white paper. So this was a paper, they have a Journal of Innovation that was started, and that's continued actually. Just incredible resource of just different types of information, different themes through that. So we got that article in, and we went from a concept to a lab environment, to a pilot factory, to full production and manufacturing. We actually ended up also, as a result of that, getting a grant with the Basque Country for over 3 million euro. And so it became one of the most successful test beds within the ISC. So when I became available, 2 weeks into the formation of the Digital Twin Consortium, I was asked to help to provide technical direction, facilitate that growth. And that's what we're really going to be talking about today, is looking at that from its early stages and what the growth is that we've seen, the adoption, and just the fact that really, I think that we see digital twins across virtually every major industry. And that's a testament to the fact that digital twin is a true enabler, a key enabler to digital transformation.
All right, great. So can you tell a little bit more about what you also do at the OMG, the Object Management Group, and how that work relates to what you're doing with the Digital Twin Consortium?
Absolutely. So OMG is a umbrella organization. As I said, it's a community of consortia. And so one of those consortia is the Digital Twin Consortium. So as a part of that, looking at that, understanding what really, if we look at it in the context of with the consortium itself, cutting through the hype of digital twin. There's a lot of hype out there. There's a lot of definitions. In fact, we just released today, the revision of the definition to encompass the areas of digital engineering. So those key attributes, the advanced methodologies for model-based design, model-based systems engineering. And on top of that, looking at it in terms of the lifeblood of the digital twin being the data that threads between the different phases of the life cycle of the digital twin. So we just announced our press release encompasses the fact that we have two revised definitions, one about the digital twin and the second about the digital thread. And now what we're going to be talking about is how that is actually going to open up the doors to the other consortia as a joint working group, because it's going to bring the expertise of the OMG SDO. So if you're not familiar with the SDO from OMG, that was formed 35 years ago, and it was all about creating standards. They developed SysML, System Modeling Language, Unified Modeling Language, several others, and continued to build that out. And also seen tremendous success within the SDO in terms of membership. I don't know, Karen, correct me how many members. I know it's well over 200. So that's a compliment. The other consortia we have, another consortia, is Augmented Reality Enterprise Alliance. And that's looking at augmented reality in the context of enterprise class. It's not on the consumer side. And so that brings the likely companies together, such as Lenovo, such as Ericsson is a member, Magic Leap is a member. There are many others. I think there's over 50 members now as a part of that. So we now have this collective expertise, and combine that with Digital Twin Consortium. We had announced, I think it was beginning of the year, that we have now integrated in, from a complementary point of view, the Industrial Internet Consortium I was talking about. So we have brought the membership of the DTC from originally a little over 50 members over 4.5 years, which is hard to believe it's been 4.5 years, to over 200 members. So, and we continue to grow and across as many different areas. That's where I can talk about it in the context of our steering committee and membership that we have. It's across industry, it's across academia, it's local government, as well as let's say the startups, the technology providers, the innovators. And so as a result of that, we go from startups all the way up to trillion-dollar companies. On our steering committee is Microsoft, is Dell. Dell is the chair of our steering committee. We have BP. We have a company called Sev1 Tech, a government contractor doing amazing things, working with NASA, other areas. So, and we have other companies that we're right now in discussions with about joining the steering committee. So we continue to see this, I would say, just incredible adoption, this growth. We're averaging practically a new member every week. So we have these different consortia that we now, as part of our announcement about extending the scope to encompass those key attributes of digital engineering, we now are bridging that across all the community of consortia that I just described. So that now opens up and brings those areas of expertise. We are, I don't know when this will get published, but we are also going to be announcing a very similar approach, back to your question about how I tie in with the OMG, where we're looking at that from areas of commonality that we can now bring together and align and harmonize. And that is around artificial intelligence. So we now have established an artificial intelligence joint working group across our consortia. So you're seeing this convergence to bring the expertise of our members together across these different areas. Again, OMG bringing in the idea from the standardization, from the ontologies, from the semantic standpoint. What is that intersection with AI? How is that benefiting? What are those contributions? And what are some of those challenges? Then we bring that in from the other side in terms of how do we visualize that data? So go beyond simply the augmented reality and go to extended reality. So we now have both augmented, mixed, and that leads right into virtual reality. So we have a very clean progression from that perspective. So what is the intersection of AI there? How is that making, bringing efficiencies and productivity, building models more easily, all these different aspects that now we look at from that perspective. Then from the Digital Twin Consortium and Industrial Internet Consortium, since we've now combined, is looking at it in the context of interoperability and intelligent automation. How do, if you think about it, how do multi-agent, how does an agentic approach, generative AI, really help to facilitate that? And does it? And what are some of the challenges? And then the other aspect to consider as part of this joint AI cross-consortial working group is responsible AI, the societal aspects, the ethics aspects. Can I have repeatable AI? How do I ensure the data provenance of what I'm using as the basis? So now you can see bridging all of those consortia and that bringing that level of expertise, how we can now really make and bring out really impactful deliverables across these areas.
You mentioned that there are a lot of definitions of digital twins and that you just came out with one yourselves. And being that you are the Digital Twin Consortium, I think yours might lend some weight. Can you summarize how you in the organization defines digital twin?
Absolutely. In fact, when we formed, the first thing we did was we got together and created a terminology and taxonomy working group. We actually added to that the technology because these areas in horizontal. So if you think about it, we're structured in terms of the different verticals as working groups. And our original four founders, each one was a co-chair for that working group specifically. And the start where Digital Twins had their beginning was in aerospace and manufacturing. So we had those two working groups. Then we also had another founder that was tied into natural resources. So that brings in not just oil and gas, but also mining. It brings in alternative energy sources, which would be wind, solar, hydro, geothermal, these different aspects. From there, we put a process in place and we continued to build that out based on members' requests. For instance, we had a member join and said, what about healthcare and life science? Absolutely, we have a process. Let's bring that forward, follow the process, establish what that charter is, the viability of a working group, where digital twins would be impacted, what type of deliverables, impactful deliverables, would we be able to bring out of that? What's the interest within the consortium? Get that approved through the steering committee. So that process follows through, and we built those working groups from 4 initial working groups. The other original was infrastructure. Think about scaling from a smart building to a smart city. We built that now to, I believe we have 14 different working groups, and that's all member driven, all specifically focused in there. So the very first task we did was to get those original 50 plus members, call them groundbreakers, to agree on what are the foundational elements of a digital twin. Because you could ask anybody and you could get, at a company, you can get 10 different answers, right? We talked to one company that said, oh, well, even here we have still different areas that they all say they're doing digital twins, but there's no common agreement. So we put those foundational elements, and that was the very first thing we did. It took, I think it took over 6 months, believe it or not, to get agreement through the team. And then we got it approved through the steering committee. And it really came out as being those foundational elements being a virtualization of a physical entity and or process. Think about supply chain management. And from that perspective, having a synchronization mechanism, that was really the key, a synchronization mechanism to allow data or information to flow between from the real, the physical entity or process back to your virtualization. That allows you to ensure precision and accuracy, the requisite level of fidelity needed for that to represent that. And that's done at a given frequency. So as long as you had a synchronization mechanism, you had a way to capture that data, gain that actionable insight, then you could actually use that to then optimize your physical entity. So you almost have a closed loop in that context. So to get agreement to all those terms, believe it or not, that's what it took, but we got that through, we announced that, published that, we gave examples, and then we built use cases around that. So we have a reference library of use cases, and the first thing to be a part of that digital twin use case was to show how those foundational elements are incorporated into your use case. So we actually now have, I believe it's close to a dozen of these use cases that follow the different types of work product we built, the frameworks within the consortium, and created a workflow, and all of the use cases and case studies as part of that reference library adhere and follow that prescription. And you can now download those directly from our site. So we call it a technology showcase on our website. You can go and you can take a look at those. And we've had many folks and companies say, hey, this is very helpful for us. We appreciate that. The definition came out, and then we built out these frameworks. The next step was, all right, how do we look at it in the context of developing a digital twin? How do I start my journey, right? So based on a discussion with one of our members and their end customers, they came out with this concept to really look at it in terms of a technology agnostic approach. How do I look at it from we'll take a page out of the jobs to be done book, right? What is the job I'm hiring the digital twin for? And based on that job, what are those capabilities necessary to complete that? And let's put that in a very familiar format so people can understand that. Let's take a periodic table. Let's remove the elements of the periodic table and replace those with the capabilities. And let's group those capabilities in terms of the acquisition of the data, the cleaning of the data, the analysis of the data, the security and the trustworthiness of that data, the visualization of the data, and the management of that data. So we came out with 61 capabilities, I believe it is. We just a couple months ago revised that based on some feedback from our members. And that's been one of the most, I would say, downloaded work product we've had within this consortium, thousands of downloads. And to this day, we still encounter companies that say, even they're not members, say, oh yeah, I use that as a framework for developing my twin. It really gives me multiple areas that I can show where my strengths are, what capabilities I'm weak in, how I can supplement those. So they use it as a strategic planning tool. They also use it as a way to ensure that the understanding between these different companies or different areas, segments within the companies, that they understand those interdependencies. And so we've just had just tremendous feedback from it. Some companies have used this, adopted it across their entire organization. And we keep hearing stories like that. So we've actually now made it machine readable and be able to now, we've had one company that joined us, and companies are joining us, which is really interesting because of the fact this is so great. I have ways that I see I can use this. I'd like to be a part of what that next version is coming out. We had one company who adopted that. They basically put a JSON script around it. They automated the whole thing. So they operationalized and mechanized that. And it allowed them to be more efficient in terms of how they would deliver a digital twin to their end customer or talk and speak to that. We had a story where one customer said, one of our members said, yeah, we were in a discussion. It was a very high level, major oil and gas company. One company spoke up and said, yeah, well, we're doing the digital twin here. And they said, this was an exec that corrected them. It said, excuse me, you're doing one capability of this. Let's understand it in that entire context. So we're seeing this as being a very valuable tool, this whole concept. We also came out with a platform reference architecture framework, and that now gives the next step to what we're calling the composability framework. This composability framework starts with a business maturity model. What is your acumen and understanding of digital twin? From that perspective, then go to the capabilities based on what you're looking to achieve or accomplish. What is the challenge? What is the problem you're looking to address? And then from that perspective, where within a full stack do you see that expertise coming out, or where are those deficiencies? And then move to the implementation. So what we're really done is taken it out of well, I want a digital twin that's going to use this technology, the point of what is your challenge? What are you addressing? What are the capabilities you need? Then what is the optimal technology? You may not need to use a neural net. You may be able to use pure stochastic, pure algorithmic, or you may be able to use just a simple dashboard. But identify what that optimal technology is, then look at it in the context of what data do I have available? Do I have the most accurate data available? Do I need to supplement that for more precision with synthetic data? So you follow this sort of methodology, and we've written numerous articles on it. Our members have adopted this, and our reference library is all about that. In fact, you can go to our website under the initiatives. It says Technology Showcase, and you can download those reference designs, and you'll see they have exactly those elements as a part of that.
But I'm just curious, do you have a pat 30-second description of what you call a digital twin when someone just asks you that question? Or do you just say it's complicated?
No. What we say is, well, originally what we said was it's a virtualization physical entity or process with a synchronization mechanism at a given frequency, quote unquote real time, because you may need, depends on what the application is. It may need a millisecond update or second or minute or day or hour. It all depends on that application with the given requisite fidelity. That's the precision and accuracy that you need to be able to maintain that. That's the abbreviated, really the short. There's other, that's the what, and then we have supporting bullets behind the how, the where, the when, the why, those different aspects. The revised definition now is looking at it because, as we said, we've now extended the scope of the consortium to look at those key attributes of digital engineering, that being the model-based development and the digital thread. So we've revised our definition, and that definition is about I'll get it. It's about trying to go off the top of my head. A digital twin is a integrated, data-driven virtualization of a physical entity and or process with a synchronized interaction. So we've added the words integrated and data-driven. So now we can tie into the model-based aspect or model-based development. And we've added the word synchronized interaction. So now we can tie in the digital thread. As opposed to a synchronization mechanism, it's a synchronized interaction. So from those really minor changes to that definition, you now can see those different aspects, I would say, more clearly. And now we can go back through our reference library, which is what we're doing. And for these designs that we have already for these use cases and case studies, we can now identify those elements. What attribute was used for the model base? What aspect? How did you do that? What was your continuity? Where is that digital thread? And that digital thread goes from conception all the way through the decommissioning, because there's valuable information there. That's that actionable insight, that's understanding. And as I said, with the digital twin being that closed loop, you now have that opportunity to take that actionable insight and optimize your physical entity or process. Using that, you can potentially prevent unplanned downtime. You could prevent a catastrophic failure. You could optimize your energy use, your amount of waste that you produce, the amount of water that you use. So there's many different aspects that you get, and that true value comes out through that closed loop.
Okay, so our audience is mostly civil and structural engineers designing the infrastructure of the world. They typically buy into digital twins. They may not necessarily have the capabilities or the assets to be able to use a digital twin. So how would you explain to them what the importance of trying to use more digital twins, how they can help them in their infrastructure work, and then maybe how the DTC can help them accomplish their goals?
I think number one, we have a AECO working group, an architecture, engineering, construction, operations working group. I think that's one area. There have been numerous white papers that have been brought out, reality capture. There's one that's coming out around locational capabilities in the context. How does that bring forward? How is that utilized by digital twin? If you think about it, the standard has been BIM. So a digital twin really brings a BIM to life. And one of our members, the co-chair of that working group, is from Esri. They've been working with NIBS on a paper to talk about exactly that. What is the role of digital twin in these areas, and how does that intersect between a BIM what are those differences between a BIM and a digital twin, and where are those values? That's, I would say, for folks that really want to understand that working group has produced quite a bit of material around that work product, and that's published on our site. But at the same time, the opportunity to come and learn more and be a part of that is there as part of becoming a member of the consortium focused on AECO. So there's multiple areas, different aspects from that perspective that could be able to be brought out.
How would you describe the DTC's role? And are you trying to outreach for awareness of the things that people can do? Or are you trying to provide a platform so that people can work together to improve digital twins and make them better? How much do you spend on both of those two factors?
I think it's really a combination of those. If you go back to our original mission and vision, the mission is really to look at it in the context of, number one, cutting through the hype of digital twin through demonstrated real world applications that showcase the value of the digital twin at the different phases of its life cycle. And I think that's, again, you've seen I've discussed some of the examples of how to start your journey of a digital twin, some of the areas of focus, and those different capabilities we cover. Each of those different capabilities we cover within the consortium through our working groups, through our subgroups. I think that's really the best thing to do as a starting point, is to look at some material that we have out. There's quite a bit. There's a lot of different videos from industry leading experts. I strongly advocate there is no other consortium that is member driven like this, that has the depth, the breadth, the level of expertise and experience in developing, in deploying and operating and maintaining digital twins as this consortium brings together.